Hello guys, today I'm going to start the JavaScript engine topic and which includes some history and how it works. Guys, if you have not subscribed my channel, please subscribe it and press the bell icon to get the notification for the upcoming videos. And also don't forget to like the button if you like it. So let's begin with so the first section is I'm going to talk about the history part. Okay. So who created the first JavaScript engine? Brendan Peake in 1995. He developed the first JavaScript engine for Netscope Navigator browser, and this browser only has the interpreter. So that time it was called as the interpreted language. Okay. So initially the JavaScript was the interpreted language. Okay. Yeah. And then as this browser has only the interpreter, so it was just reading your code line by line and creating this machine code or is a byte code which can be executed by the machine, but it is not optimized or the performance oriented. It's actually it has lots of drawback in the performance. Okay, so the new engine which Google has created in 2008. Okay, this is the first modern JavaScript engine. Google created V8 in 2008. Okay, this is using the compiler and interpreter both. So this has interpreter plus compiler. It employs the JIT compiler, JIT compilation page. Okay. So we have four main popular JavaScript engines. One is V8 for the Chrome, and then we have WebKit for Safari. Then we have SpiderMonkey for the Firefox. So this SpiderMonkey is the same JavaScript engine which was developed by the Brendan for the Netscope Navigator browser. And after like modification and enhancement, now it's renamed as the SpiderMonkey. Okay. Then next, the popular we have Chakra. This is for the Edge browser. Okay. So these are the four main browsers, the popular browser, but we have big list actually out of these four as well. So you can find that list in ECMAScript engines. Okay, so these are the total. We have multiple JavaScript engines. You can go through with this whole list and understand like for which browser we are using which one. Okay, so and don't get confused about this ECMAScript engine. This ECMAScript is the standard specification for this JavaScript, and which is managed by the TC39 committee. So I think each JavaScript engine must follow this ECMA standards. Okay. So So here, the next is how the JavaScript engine works. Mainly, I'm going to taking this Chrome V8, and all the modern JavaScript mainly follows this Chrome V8 architecture. There are some compilation, maybe some of the JavaScript engine have some difference in the compilation, how they do this compilation. But overall, the architecture I think is remains same for all the modern JavaScript engines. Okay. Now, this complete JavaScript execution I'll be dividing into 3 phases. Okay. Number 1 is the parsing. Okay. Then second we have compilation. Third is execution. Okay. So this compilation again, I'm going to divide into 3 parts. Okay. First is HTML parser. And second is we have byte string decoder. Third is we have JS parser. Okay. So let's understand first HTML parser. Okay. Here we have HTML file. Let's consider this as a index.html file. I'm just taking this example as the index HTML because this normally in all server, this is the first file which gets processed. Okay, so this index.html file will have multiple tags. Right? We have head, and then we have body, and this I'll just close it here. Body has some, let's say, consider the h1 tag, and it will have welcome, and then we have a script tag. So normally this script tag always come at the last of the body tag. Okay. And this script tag has the source, and the source, let's say, I'm giving the name as script.js file. Okay. Close this body. Okay, so you definitely have some other codes here after the h1. It's not only this. I will say this. Okay. This is our index.html file. So HTML parser start this parsing the index.html file from top to bottom. And when it finds your script tag and see the source as test.js file, it start loading that file. This file, maybe it come from the network. Or maybe it's like sometime it can come from the browser cache or from service worker. Okay. Now, when this JavaScript file loaded to the HTML parser, it loads as a stream of bytes. What is that? Is a stream of bytes. And this is UTF-16 format encoding. Okay. So let's say your JavaScript file has the function named as, let's say, function display and something like this. Okay. So each character of this file, of this JavaScript file, will be converted into a stream of bytes. Okay. So just to give the one example to more clarity, this function function. So if you talk about this function keyword, let's say your f will be converted as 66 and u will be converted as a 25 and n is converted as a 60 and something like this, and then maybe n is converted as a like 60 something. Okay, so this is your stream of bytes will be the final output from HTML parser and will be the input for the byte stream decoder. Okay, so you have this one. Now this is your okay. Byte stream decoder will read through all these streams of bytes and will decode it again as in the format of the notes for the keyword, for each keyword or each identifier and numeric numbers, and it will identify if your code has like all the like keyword or the numeric. So just to give the as example, it will have like function one, and then it will have function and then display, and one more maybe it will have these are the nodes of token which is going to come from the byte stream decoder. Yeah. Okay. Just like this. Okay. And all these nodes are going to pass to the JS parser. Okay. So these nodes are the input for the JS parser. Okay. Then JS parser is going to understand all these nodes and will form a abstract syntax tree that is called as a EST. Okay. So now it is going to convert it as an EST. Abstract syntax tree. So when you get this abstract syntax tree, you will be thinking how it looks like this abstract syntax tree. So let's see this also, how it is going to look like. Okay. I'm just going to, I'll just delete this. Okay. So this is, I open this EST site. Here you can see this how is EST are created and how it looks like. Okay. So I'll just type it something constant. Let's say number equal to 10. Okay. And when you type this, this is getting converted as the EST. This is our JSON file, but the tree structure will look like this as well. Okay, but it's you can consider this as like JSON file. Okay, so this is how it looks like. Maybe you can do some more research here if you want to go deeper into abstract tree level. Okay, so till here, like this is complete a parsing process is done in the first phase. So if you see this diagram here, we have covered till abstract tree. This is the our parsing phase. Okay, next is like here we have compilation phase here. Okay, so this is our compilation phase. Now if you, I'll just, so before going to the compilation phase, I want to cover 2 points, which is interpreter and compiler. Okay, so this is interpreter. So here this should be very, you should actually focus more here to understand the same interpreter and the compiler concept here. Okay. So interpreter mainly is execute your files and convert the code line by line and create the executable format. Okay, so this is line by line execution process. But in compiler this do the compiling in 2 steps. One is in the first phase, it will load your whole file and then understand that code and do the optimization in the second step. Okay, so that's how it's like different. And why we say and due to that reason is this compilation process is little slow. Okay, so here you can write this is slow comparing to the interpreter. Okay, this is first. But the code wise, this is more performance oriented because this do the optimization as well. Okay, so this has efficient code after that. Efficient. Okay, so so now if you understand like why the interpreter when it has only the in the first JavaScript engine, it has only the interpreter and it was impacting the performance. So due to that, in the next development, the Google came with the interpreter plus compiler. So it will solve both purpose, right? So due to that is like Google introduced this like JET compilation, and in the JET compilation, interpreter and compiler both works together. So at a time it is not only like it's a interpreter can do only everything. So the first step, your file will be loaded. Let's say JavaScript file is like big file. It doesn't mean the whole code is going to be executed at the first moment, right? We have like lots of event binding concepts, right? Lots of code is there. So like when you do some action, then only it will execute. So the interpreter is going to first a few bytes going to provide to your CPU very fast. Okay, so I'll just learn a little bit more here. Delete this. Let's say you have your CPU here, and so what would be the input for this? Is your ESP, which is the input for the interpreter. Okay, and so initial few bytes interpreter is going to provide to the your CPU, and so that CPU is like no need to wait for the longer time to do all the compilation and things, right? So few bytes initial few bytes will be provided by the interpreter to the your CPU, and when the CPU start executing those initial few lines of code, then in the background your profiler and compilers comes into the picture. Okay, this is your profiler. So profiler mainly help to identify what are the hard section in the code are there, and those can be optimized. Plus, it helps to identify any blocker or any like wherever it will see the code is like is not effective, right? So it helps to optimize and to telling this compiler uh, what are things we need to optimized in the in code. Okay, let's just finish this. Now, one last thing is this compiler is going to provide you the optimized code. Okay. Okay. So this optimization happens here, and this will happen in multiple phases. Right? It's not only in one go. In one go, it can do the whole optimization. So this is like in multiple like phases. Compiler and interpreter and profiler works together and to do the optimized code, and then this optimized code will be executed by the CPU. So this is how it's going to looks like this overall cycle. And also just want to mention 2 points here, which Google has introduced: ignition interpreter pipeline, and then the second is the turbofan compiler. Okay, so initial, like when I was talking about this interpreter and the CPU goes, this is actually your ignition interpreter cycle. Okay, and the next bit, like where is do all the optimization and things, this is coming to your this turbofan cycle. Okay, so just to mention those points. So this looks, I have explained this, the compilation steps here. Now the third is the execution, right? On execution cycle, it is going to use this event loop, plus it has some call stack memory heap to work like together. And I'm going to cover that point when in the next video I'll be explaining the event loop. I think it's better to cover on that point. But here, the first, these 2 points about the JavaScript engine is like parsing and compilation. These are, I think I have just explained here. Thank you guys for watching this video. Please don't forget to subscribe, like, and press the bell icon to get the notification for the new video. I am planning to publish one video every Sunday at 12 p.m. So please watch it.